Alright, going on to example 4, the very last example we can see, on to example 4, the very last example we can see there's going to be a few things a little bit different, but let's just go into the description first. The Vallence Cheese Company of Warrnambool, state here in Melbourne, Australia, for those of you watching outside of the country, produces 2 cheese spreads by blending mild cheddar with sharp tasty cheddar. 2 ingredients, 2 cheese spreads, 2 variables. The spreads are packaged in a jar of 300 grams net and distributed. So that's the 2 different spreads. So we got the standard spread, which contains the cheddar and the tasty cheese, and then the Extrabite spread contains 60% of mild cheddar and 40% sharp tasty cheese. And then we've got limits on the amount of mild cheddar and limits on the extra tasty cheese. And jars of bread spread sells for $4 each. Formulate the LP and sketch the feasible region. You can cut. Okay, we've got 2 variables here. We've got 2 ingredients. But the different thing in this example is that we're dealing with percentages, and which are not quite exact values. So we need to know how to convert the percentages given the context. So the important part to notice here is that the spreads are packaged in jars of 300-gram net, but each spread has their own relative percentage. So the standard spread contains 80% mild cheddar, 20% sharp, where the other one contains 60% mild cheddar, 40% sharp. So what we want to do in terms of, like, say, a bit of pre-processing, to use a data science term, is that we want to convert the percentages into grams. So just to do a bit of work first. So if we've got a jar of 300 grams, and then we say, okay, the standard has 80% cheddar, then what does the question is, how much cheddar is that in grams? So 80% of 300, so that's gonna be 300 minus 60. I'm thinking 1 minus 20%. So that's gonna be 240 grams of cheddar, and then the other one is 20% sharp. So 20% of 300 grams is going to be 30 times 2, 60 grams of sharp tasty cheese, apologies. And the other one, the other spread is standard spread Extrabite. So Extrabite. The Extrabite is, in this case, 60% mild cheddar. And then converting that to grams, 60%, 6 times 3 is, no, that's not right. Sorry, 6. So in my head, I had 6 times 3 equals 24. Should be 6 times 3 equals 18. So that's going to be 180 grams. And then Extrabite is going to be 40% sharp. So 3 times 4 is 12. So this can be 120 grams. And then we can check that they pour each of the spreads to add up to 300. Okay, so given 600 kilograms of mild cheddar, 300 kilograms extra tasty cheese available this month, jars of bread spread sell for $4 each. Formulate the LP and sketch the feasible region. So we're still gonna have to do a bit of number crunching before, but we can jump straight into the decision variables. In the thing I was trying to formulate in my head was that in terms of, like, the order that you address things, even though I try to do things in terms of, like, pre-processing, decision variables, objective function, constraint, you don't necessarily need to do them in that order. But when you do present them in, like, say, an assignment, or, if you're just writing things out and you present it to other people, that's how you will want to present them. But in terms of working them out, you can do it any way you like. So, and I'm just kind of doing just to be reasonably consistent with the order that I've kind of just started with. So in this case, the decision variables should be S. So we were making 2 products once again because it's a 2 variable LPs, and in this case we're making jars of spreads. So, and then we've got this. So we've got standard and Extrabite. So I'm gonna make S be the number of jars of standard spread, and then I'm gonna make E be defined as the number of jars of Extrabite spread. So that's our decision variable. Notice like before, I've also defined the units. So that's how this basically works. So next is the constraints. So I'm gonna do the constraints on the. Oh, sorry, not the constraints. The objective function. Sorry, function. And the objective function is pretty straightforward. So jars of both spreads sell for $4 each. It's implied here that we want to maximize sales, we want to maximize profit, and because I don't think that's actually kind of specified in the question. So objective function in this case is that we want to maximize. In this case, both spreads sell for $4 each, so it's going to be 4s plus 4e. And then for the constraints, it looks like we're going to have two constraints because we've got two ingredients, and both of these ingredients have a capacity which is in kilograms, not grams. So we want to, so you want to decide on what constraint or basically like how much of a constraint you want to have on in terms of sorry, you want to decide on what units you want to have your constraint in. So there's a few different ways to address this one. So we can address this on a case by case basis, or we can kind of do like we can try and multiply the whole thing by a particular constraint. So so first we're gonna start with the mild cheddar availability. So the cheddar constraint. So the more straightforward way to write this would be that if we have a jar of standard spread, and so if we have a jar of standard spread, which is going to take 240 grams of cheddar per jar standard spread, then also because the restriction is in terms of kilograms, so what I'm going to do is I'm going to convert everything to kilograms first. So 240 grams in the top right, that's going to be 0.24 kilograms. 60 grams, that's 0.6 kilograms. And then 180, 0.1a. 120, 0.12 kilograms. So that allows us to convert things pretty easily. So that's going to be for the standard spread 0.24s plus and then for the Extrabite that's going to be 0.18e. It's going to be less than or equal to 600. And then for the Extrabite, for the sharp cheese LP, we could do the same idea here. So for the standard, we have 0.6s plus 0.12e, and the amount we have in total is gonna be 330. 330. Okay, so now there's actually a different way you can formulate it, and you will actually end up with the same result. So so it's kind of just a very alternative way of thinking. Both ways result in the same constraint. So I want to try and be able to explain this one. So so for the cheddar. So what I want you to think about now is that I'm trying to think about how to phrase this. So what I want you to think about now is that in terms of the cheddar availability, you've got 600, and then you've got a jar of, and then for the standard jar, you've got 80%. For the jar standard, you've got 80% cheddar, so it will be 0.8 s plus 0.2e. Now, but this isn't quite the whole picture, because what we're missing is that when we are measuring the jars in terms of sorry, something is not quite right. Alright, sorry about that. I paused the recording because I just had to sit down and kind of just really think about how I wanted to explain this. So what we have here at the moment is that we've got 0.8s plus 0.2e. I want you to think about what they actually represent, because it's actually 0.8, which is the percentage of mild cheddar in the standard spread, but it's not actually given a unit. You can think it's actually in terms of grams, but in terms of the representation of 0.8s, as far as we're concerned, is in actually terms of kilograms. But the important part is that we've got the 600 on the right, which is which means we're in kilograms. So now, so what we actually have to do as a result is that we need to kind of coerce this expression into kilograms, and since each jar is 300 grams specifically, that's why we put the 0.3 on the front. So I haven't explained this in the best way possible. At least I haven't explained it in a way that makes sense to myself. But if this is a way that works for you in terms of thinking about how to formulate a problem, then this one will work just as well. So in a similar sense for the sharp cheese, what we have is that if we look at the percentages, we've got sorry, for the sharp cheese. So for the standard spread, we've got 0.2 S because that's the percentage, and then plus as well, we've got for the Extrabite, that's going to be 40%, that's 0.4 E. So that's the percentage. So once again, that's the percentages of sharp cheese in each of the different spreads, and so that's going to be less than or equal to 300 kilograms. Sorry, 330. Sorry, I don't need the kilograms. And then, like before, we want to multiply the expression on the left by 0.3 to properly coerce it into, say, 300 grams, so that the whole thing is less than or equal to 330. So, if you've got a better way to explain it, put it in the comments below, and I might go ahead and re-record this video. So, but the most important thing you notice is that once you multiply out the expressions are actually equivalent. So I do want to stress that there is certainly more than one way to think about certain constraints given an appropriate amount of leeway. So now, so I'm going to jump straight into sketching the feasible region. I'm going to jump straight into sketching it. So at this stage, you have my permission to stop watching and just jump straight into the solution of the result. But for those who need a bit more practice, feel free to follow on. So what I'm going to do first is that I'm just going to rewrite the constraints into something that's a bit more easier to understand. So this first one is going to be 4s plus 3e is less than or equal to 10,000. And then that's good. And the next one is going to be s plus 2e is going to be less than or equal to 5,500. Okay, so, and we've only got two constraints, so this should be reasonably easy to sketch. So, so once again, I'm just gonna go through the intercepts in my head. Well, I'm kind of actually no, I'm still gonna write them down. Okay, so if I have s equals 0, e is gonna be 10,000 over 3, so that's going to be 333.3 repeated, and then if e is going to be 0, then s is going to be equal to 2,500, 0. And then for this one at the bottom, if s is equal to 0, then e is going to be equal to 275, 0, and then if e is going to be 0, s is going to be equal to 500, and then 0. Alright, so, and then now I should be able to sketch both these functions pretty easily. So, so that's going to be 333.33. So my largest number is going to be 550, so that's going to be my 550. So that's going to be on my, once again, I need to label my axis. So that's going to be s as the x-axis, e as the y-axis. Alright, whew, so much to do. 550, so that's going to be around here, and then there's 2750, so that's going to be roughly around something like that, 5500, 2750, and then that's going to be s plus 2e is less than or equal to 5500. So put the arrows, and then let's pick a different color. Okay, and then the other one is 2500 up 0. And then 333. So that's going to look something like that. So I'm kind of just spitballing it. So I'm not going to be too picky as long as the ratios are roughly right. So that's going to be 10,000 on 3. That's going to be 2500. And that, sorry. Whoop, no divide. And then the arrow is going down that way. So you can, once you combine the feasible regions, you should be able to sketch that reasonably easy. That's straightforward. So that's your feasible region right there. So that's it for the 4 examples of 2 variable LPs. And so on the next video, we'll start looking at how to solve them given the objective function and using what I personally call the graphical method. And in this case, it's really only a method that's suitable for 2 variable linear programming problems. So until then, enjoy kind of just thinking about how you would formulate different LPs, and if you've got examples around, make sure to have a crack at them and see how you think about them. Until then.